This is the video solution to one of the example problems involving uniform circular motion and solving them using ratios. A rock is tied to a string and swung in a horizontal circle around your head. The velocity is doubled. The new rock is twice the mass of the original rock and is now attached to the string. The more massive rock is swung around by the same centripetal force as before. By what factor did the string's length change by? So let's first start by looking at our givens in terms of factors of change. So if I look at the givens, the first thing I notice is that the velocity is doubled. So that means I have 2v. The next thing I see is I now have twice the mass. So that's going to be 2m. That m is not meters as a distance, but mass. And it has the same centripetal force. So the same centripetal force, that's just going to be F, or 1F if you want. Now it says, by what factor did the string's length change by? Well, if it's twirling around on my head at the string's length, then really what it's asking for is the radius. So it wants to know what happened to the radius. So I want to figure out what happened to the radius here too. So here's my strategy. When I look at this, I can see that I don't have enough variables just to use one of the circular motion equations. I need another variable for circular motion, and I can find that from F equals ma. So what I'm going to do is I'm going to find the factor of the centripetal acceleration, its factor of change, and then I'll have the other variable once I have how a changes, by what factor it changed by, and I'll use my circular motion formulas to figure out how the radius changed. So to begin with, and I'm going to use F equals ma to find out how the a, because I have the F and the m up there. So I'll start with F equals ma in the denominator, and in the numerator I'll put the same formula with the factors of change. So the force stays the same, it's twice the mass, and x times a. I want to figure out what happens to a. I divide out every variable that's the same, and that leaves me with a new equation with just the factors. So 1 is equal to 2x. Therefore, x is equal to a half. So the acceleration changed by a factor of a half. So the new acceleration is a half times the old acceleration. So that's one more given I have in my list. Alright, so let's see. I've used up 2m, and I've used up the force. I don't need to use them again. So now I'm just going to look at the remaining ones. I got v, r, and a. So I need a formula with v, r, and a in it. Well, with v, r, and a in it, that's going to be the ac is equal to v squared over r formula. So I'll put that in the denominator of a big formula. And in the top, I'll write the same thing again, this time with the factors of change. So the acceleration is a half. That's a half a. And that's equal to 2 times v. And remember, that's 2 times v squared divided by x over r. So I'm going to divide out the like terms. So the ac's go away, the v's go away, and the r's go away. Notice that the squared term didn't go away in the numerator. It's still there. So the v squared went away, but not 2 squared, because that squared applies to both of them. Whatever happens to the variable also happens to the factor. So the variable was squared, so is the factor of change. So my new equation is a half is equal to 2 squared divided by x. So therefore, when I cross multiply, I get a half times x is equal to 2 squared. So x is equal to 8. So the final answer is the new radius is 8 times the old radius.